Welcome to Summarize Science. Recently, the world of cosmology was buzzing with excitement over a potential breakthrough from the Dark Energy Spectroscopic Instrument, or DESI. The collaboration announced it may have found evidence that dark energy, the mysterious force accelerating the expansion of our universe, is not constant but is actually changing over time. This would be a monumental shift in our understanding of the cosmos. But as with any big scientific claim, it's crucial to look at it from every angle. A new paper from researchers at the University of Cambridge does just that, reanalyzing the same data with a different statistical toolkit known as Bayesian analysis. They wanted to see if the conclusion holds up under a different kind of scrutiny, one that is particularly good at accounting for model complexity. And what they found is fascinating and stands in stark contrast to the original announcement. For the key combination of data from the DESI telescope and the Planck satellite, their analysis did not find strong evidence for evolving dark energy. In fact, as you can see in this table, their results slightly preferred our current, simpler model where dark energy is a constant. This is a direct contradiction of the original paper's high-confidence result for the exact same data combination. So where did the exciting signal for a changing dark energy come from? The researchers found that the preference only appears when a third dataset, a catalog of supernovae called DESI, is added to the mix. This specific dataset seems to be the key ingredient driving the conclusion. But the story gets even more interesting. Their deep dive revealed a significant statistical conflict, or tension, between the DESI data and that specific DESI supernova data. Essentially, under our standard model of the universe, these two major datasets do not quite agree with each other. The new evolving dark energy model is preferred in this case precisely because it's more complex and has extra flexibility that can smooth over this disagreement. It's like using a flexible ruler that can measure two slightly misaligned points by bending a little. So let's recap the important points. The original claim of strong evidence for evolving dark energy is being challenged by this new Bayesian analysis. The evidence seems to be less about a revolutionary discovery and more about the new model's ability to resolve a conflict between different datasets. This doesn't mean the original result is wrong, but it does add a huge layer of caution to the interpretation. It suggests the preference for a changing dark energy might be a statistical artifact of combining tense data rather than a true signal from the universe. What this means for the future is that scientists need to carefully investigate why these datasets disagree. Understanding these tensions is the next critical step before we can confidently declare we've discovered new physics. It's a perfect example of the scientific process in action. Claims are made, they are rigorously tested, and our understanding gets refined with every step. Thanks for watching Summarize Science.